Hi, this is Vince Marino with Lunch and Learn with Vince. My guest today is Rob Marsiglia with Asahi America. My goal today, and every day that I do this, is to share information with you that I consider tribal knowledge. And the goal here is to prevent the loss of this tribal knowledge so years from now, people can avoid mistakes or look at historical data and say, hey, that's what I'm trying to achieve, and not make some of the mistakes or learn from some of the people that are on these lunch and learns. So without further ado, I want to introduce Rob Marsiglia with Asahi America. Rob, welcome.
Thanks, Vince. I appreciate it. Glad to be here. Glad to be with you.
Well, tell me a little bit about Asahi America and what we're going to talk today. I typically don't have a script and a plan and stuff planned in advance, because it actually makes the conversation much more interesting if I don't know what you're going to hit me with. And I've got a couple of questions for you that I've written down. So tell me a little about Asahi America, and I may have some questions.
Not a problem. Asahi America is actually, we're owned by a Japanese valve manufacturer, Asahi Yukazawa, which is, if not the largest, one of the largest thermoplastic valve manufacturers in the world. And we've been in existence here in the States since the mid-70s, and obviously started out selling thermoplastic valving, ball valves, butterfly valves, diaphragm valves, gate valves, etc., PVC, CPVC, polypropylene, PVDF, and kind of expanded from there, added to that valve portfolio a full line of primarily chemically resistant and high purity piping systems, again, in those same materials, polypropylene, PVDF, polyethylene, now even Halar, and we've expanded into the commercial or building services market with a material called PP-RCT, which handles plumbing, domestic hot and cold water, and hydronic applications, chilled water, cooling towers, condenser water, and the like. So all of which kind of tie in with the use of the valving products with those piping systems.
Okay. And where are you located, Rob?
I work out of my house in northern New Jersey, basically the New York City metropolitan area. The company is based up in Lawrence, Massachusetts, about a half hour, 30 minutes north of Boston.
Great. And if you care to give us your email, anybody that has an inquiry or comment or question or need help, this is your chance to do it. And we'll also post it in the notes. So what's your email?
Absolutely. It's my first initial and last name at asahiamerica.com. So it's RMARSIGLIA at ASAHI-America, AMERICA.com. And I do at times wish I had a much shorter email address, believe me.
Hey, don't worry about it. And from one Italian to another, I know that the G is silent. You have the silent G. I've got a lot of family with the same similar spelling.
Yeah.
And one of them on Instagram, their Instagram handle is the G is silent.
And actually, most of my sons, their nickname is Sigs, where they pronounce the G, and that's short, and that's their nickname. So yeah, it's pretty funny. But you're right, it is, the G is silent.
Yeah. Well, okay, so let's jump in here. We're going to talk a little bit more about Asahi America and piping applications and so forth. So tell us a little bit about where we're going to take this conversation today.
We can take it in a number of directions, quite frankly, because we consider ourselves experts in plastics. We like to think that we would give designers, engineers, end users real, solid, fact-based advice, if you will, and direction for the proper application of our products. And if our products won't work, we we're happy to say that as well. And if we can possibly give direction as to what products or services would work for the customer. What I'd like to focus on today, and it kind of ties into the pumps and equipment as well, is our commercial products, and in particular, the Asahi Tech PP-RCT product, which, as I said earlier, is a commercial building services piping. It's polypropylene, extraordinarily smooth, and it's a real good alternative to metallics, to copper and carbon steel, and particularly the carbon steel on chilled water cooling towers on the hydronic side of the building services. And I tie it into the pumps because of the efficiency that a facility can see when utilizing PP-RCT. One of the things we like to point out is with thermoplastics, and in this case, polypropylene in particular, it doesn't corrode, it won't scale, it doesn't pit, you don't get loss of ID or buildup on the ID surfaces. So when you install it, the performance characteristics, the flow, velocity, pressure loss, et cetera, remains constant for the life of the pipe. And the pipe can be anywhere from 25, 50, even 100 years of expected service, depending upon pressures and temperatures. Most engineers should, or if they don't, we try to direct them to this, that when you select carbon steel, there's a flow factor, a Hazen-Williams number of 140 when steel is new. The problem is steel doesn't stay new, right? Steel ages, and that number changes over time, can drop considerably to what we would term as a Hazen-Williams of between 90 and 110. So what happens if you don't take that into consideration in your pumping system, as that pipe decays, if you will, over time, and that ID surface gets rougher and rougher, it's tantamount to closing a valve in your system, and your pump begins to work harder and harder to overcome that restriction. I'm sure you guys are, and most people are familiar with a pump curve. We refer to it as moving back on the pump curve, right? So when you select your pump for the high efficiency and a certain velocity and pressure loss, if you deadhead that pump, your pressure is going to increase, but obviously your flow is going to decrease. Your velocities are going to increase. So it has a real adverse effect on the performance of your system. It's something that we stress with Asahi Tech and PP-RCT: efficiency, sustainability, green building, saving in electrical costs and the like. Never mind the performance of the system, and what your client gets is like new performance, like I said, for the life of the pipe.
That's interesting. I want to ask you if we can drill down a little bit more on the cooling tower side of things. I think you said cooling towers is one of the applications.
Yes.
So I tend to ask questions that that maybe your average coworker would already know the answer to, but I don't. So I'm asking.
Sure.
Is it a temperature issue, or is it aggressive water issue with the valve? I mean, I know the concept of the cooling tower. I've been to there's a steam plant right up, not far from me. I've been to it, and I've seen the ash that develops at the bottom of these things, and the concept I totally get. But is it the water? Is it the temperature? What is it that makes these particular valves more appealing than a metal or copper?
Like many answers, A, it depends. B, it can be a combination of those things. Water quality varies all over the country. So in some cases, it's far more aggressive than others. In some areas, it's not that aggressive, but it has a very fine particulate. New York City, for example, has very good quality water. Their city water, if you will, but it has a very fine particulate and TDS. So to answer your question, I think it would really be a combination of all of those. Obviously, in the cooling tower, when you get up to the cooling tower, there could be treatment chemicals, right? It evaporates, and that's the whole function of the cooling tower. But obviously, it affects the piping and its compatibility, if you will, to those chemicals, to the environment. Obviously, much higher humidity in that area because you're literally evaporating the water. That's how you're acting to cool it. So the benefit of that thermoplastic piping system, so that would be the pipe, the fittings, the valving, which is something that we pride ourselves on at Asahi, is the ability to provide not just a portion of the system, whether it be just the valves or just the piping, but we can provide the complete piping system that provides all of those benefits that you were temperature capability, pressure capability, and internal and external corrosion resistance, and minimize the amount of treatment chemical necessary. At least we would eliminate the treatment chemicals that you would normally put in to treat the piping system that you're handling. So
is it scaling? Is that scaling, for example?
It's scaling or pitting, either one.
Right.
Scaling would be the buildup of material inside the piping system. Obviously, pitting would be the removal of pipe wall, which contaminates the fluid that you're handling. In terms of a cooling tower, then you're depositing those particulates in the cooling tower, and you're also reducing the pipe wall, plus making it a much more rough surface. You've got bacteria, you've got the ability for bacteria to grow. Mm-hmm. So it's almost like a cascading or a domino effect when you get that corrosion activity in a piping system. And then obviously it can affect the valving as well if the valves are the same material as the piping system in terms of being metallic.
So tell me a little bit more about Asahi America, Rob, a little bit more about the company itself and the product. And the first thing I wanted to ask is, when I'm selling an Asahi valve versus a copper or metal one, is the purchasing agent going to go, whoa, that's 3 times the cost, or is it lower price? Is it more expensive? I mean, tell me, what are the objectives that happen when you're trying to sell elastomer? Is it elastomer, polymer, elastomer?
A polymer valve. It depends on, well, versus copper. Let me step back. When we apply the valves into a commercial piping system, I would say typically the valve would be more expensive. Our valve would be more costly than the metallic option. And actually, even our piping might be more expensive than the metallic option. I say this to contractors all the time. If you take my 3-inch 90 and a carbon steel 90, you may very well tell me, Rob, it's $1 more, it's $2 more, or what have you. But the whole what we sell and what we present and try to educate is the whole package, right? You're purchasing not just a stick of pipe or not just a valve. You're purchasing a corrosion resistant product. You're purchasing its performance, its cycle life. It absolutely no maintenance. Tremendous weight difference between the two. So from the contractor in terms of handling it, for example, a 16-inch ductile iron butterfly valve is literally almost twice the weight of our 16-inch polypropylene valve. One is like 16 pounds, the other is almost 33 pounds. So in terms of supporting it within the pipe system, you don't have to independently support those valves. So and that's always been Asahi's approach. We're not known in the industry as the least expensive product, but I would say we're known in the industry as a very high quality product, long lasting, and in this case, you get what you pay for. So, on the commercial side, we would certainly be, I would say, component to component, it would not surprise me that we would be somewhat more expensive. Although with the way price of copper has exploded now, just in the nature of the world as it is today, the thermoplastic piping has now become much more competitive, even in terms of pricing for carbon steel and certainly for stainless steel. But the reverse is kind of true when you look at the whole other section of what Asahi does. To answer your initial question, tell me more about Asahi. For years, we're fully ingrained in both chemical process market and high purity. So in those instances where we're selling a thermoplastic alternative to a metal product, we may very well be a polyethylene alternative to 316 stainless steel, and then the product is less expensive and it performs far better, lasts much longer. So now you start to tie in a big economic advantage over what would be a much more corrosion resistant alloy or product in steel. But to step back on the commercial side, when you tie in our method of joining, the lightweight, the ease and speed of our fusion welds versus welding carbon steel, the skill that it takes, the overall package as size increases, when we get up into a system that's 2, 3, 4 inches and above, even with hanging it, additional support because of the thermoplastic nature of the piping, we can become considerably less expensive in the overall package. And then, so the contractor who says, hey, your pipe is more expensive than this carbon steel pipe, when you look at it over the course of him installing the whole job, it becomes a less expensive installation and a far better one for the end user.
All right, so can you tell me a little bit about the fusion weld process? That sounds interesting to me, primarily because we're talking about, we're not talking about welding with a rod, so to speak. We're talking about some kind of a chemical process.
Actually, heat process.
Heat. Okay.
So there's in thermoplastics, from a fusion or welding standpoint, there's basically two methods, right? A solvent weld or solvent cementing, which is what most people are familiar with in terms of PVC and CPVC, right? You use a primer on the pipe and the coupling, and then you use the actual solvent cement and you push the two together, whether it be pipe to a fitting, pipe to a coupling, and that's how the joint is affected. From a polypropylene, PVDF, polyethylene, one of the benefits of it is that they are chemically resistant to those solvents and can actually handle them in a piping system. But then I guess you could say the drawback is you can't solvent cement them together. You need to heat fuse them. But that's actually an advantage as well because it's very fast. You're using heat, whether it be a hot plate or what we call a heater bushing, but there's no open flame. So one of the benefits on a job site for utilizing polypropylene or PVDF or polyethylene as an alternative to copper or steel where you're soldering or welding, there's no open flame. Right, in carbon steel, you have an open flame, you have the sparks. Many times you need a fire watch. All of that goes out the window with polypro, polyethylene, and PVDF. It's a hot plate, it's about 500 degrees, but there's no open flame and it contacts the material. And essentially what you're doing is where there's a male and a female, spigot and coupling, you're heating the outside of the pipe you're heating the inside of the coupling and then pushing them together. I explain it, picture solvent cementing PVC, but instead of it being cement, you've melted the outside of the pipe and you've melted the inside of the fitting and pushed them together. And when you get up into larger sizes, we utilize a technique called butt fusion, where, as the name implies, you have two plane ends, a plane end of pipe, plane end of fitting, or pipe to pipe, and you butt them together. You place them against a hot plate, melt their faces, and then push them together. And all of that is used, a machine is used to do that. In fact, you can see it over my right shoulder in the background. That's a socket fusion tool. And the nature of it is it's extraordinarily quick. Literally a 1-inch socket fusion process for polypropylene. Overall time takes a couple of minutes, and that's enabled you to pressurize the pipe and put it in service. It's kind of literally like a 15-second process to heat the pipe and join it together. An 8-inch pipe to weld it is about 30 minutes, as opposed to about an hour and 50 minutes for carbon steel. So when the term time is money is literal on a job. We know that. So my piping may be a few bucks more than the carbon steel, but it's nowhere near that much more expensive. That time savings doesn't put money in an installer's pocket. The fact that you're a quarter of the time, let's say on an 8-inch weld or a 6-inch weld, that translates to a tremendous amount of dollars, on a job site. It's funny. I talk about I'm a member of ASPE, and they have their plumbing design guides, and they show an example of an estimate, and it's a 1-inch copper installation that's about 240 feet of 1-inch copper pipe and fittings, and they show that the price of the material is about $530. The price of the install is $5,900. So you realize that you could save that installer, $250. Hey, I'll cut your price in half on the material, and it's really a drop in the bucket. But if you say to that installer, I'll cut your labor in half, now that's a significant savings. And essentially, that's what we put on the table when we talk about the thermoplastic welding, and in particular, kind of go back to your question about cost and whatnot. When we talk about the Asahi Tech product on the commercial side relative to soldering copper and certainly welding steel.
Rob, that's I'm just getting into this, but I'm beginning to see that when it comes to making a purchase, oftentimes people just look at the numbers and they weigh it between product A and product B, and I'm really beginning to see that there's a much deeper analysis that's required, and educational process. And the challenge, I would imagine, is when you're dealing with somebody that's just looking at numbers, you want to grab them by the lapels and go, wait a minute, hang on a second. But that's a
challenge. It's a challenge in the States to get somebody to look 3 years, 5 years, 10 years down the road. I think it's a really good thing that we're becoming environmentally conscious. Engineering firms are looking at sustainability, environmental impact, energy savings, because all of that does tie into this long-term look at value, as opposed to, hey, this cup cost me $1 and this is 75 cents, so I'm buying the 75-cent cup, even though the $1 one may last you 50 years and you're going to buy 10 of those 75-cent cups over that course of time. I really do think it's starting to change, and I think change for the better on a number of levels. But that's one of the things that we do in Asahi. We have a group of business development managers. I'm one of them, and we break them out into the various what we see as markets or business segments: high purity, industrial, environmental, commercial. We even have one on the marine side. And our function really is just what you're talking about now, the education side of the business. And it's why we pride ourselves in even directing engineers and users to other products or other materials, because what we want to do is give that proper education. Before we were recording, you were talking about the engineering education, and I'm an engineer by education, but I was never taught valves and valve designs and which valve is right for which application and piping selection. And that kind of falls into the market, and we consider ourselves salesmen and business development managers, but it really is what we pride ourselves in doing, is bringing that education to the engineering and maintenance and facilities space, and bringing them up to snuff on what we think is really important information to know about the products, the performance, what's happening now, what we see in the future. So it's a very, very big part of what we see our function to be in the marketplace.
All right, so let me ask you, and this is a bit of a, you weren't planning to hear this question. Can you tell me a time where you walked in and saved the day?
Sure. I'll tell you what comes to mind immediately. One of the building services piping systems that we offer is a product called AirPro. It's a thermoplastic compressed air system made specifically for compressed air. It's a specially formulated polyethylene. We have a letter from Cal OSHA that says it's suitable for use in compressed air. It's just like what we've been talking about for the fluid products. It's corrosion resistant, impact resistant, super smooth flow. But where it's really come into play is in underground applications, because for the most part, carbon steel is used in those buried applications, and over the course of time, carbon steel rusts and you begin to get leaks in the compressed air system. And in one railroad facility, we're used extensively in railroads for the train braking and also for switching within the yards. And I'm not exaggerating, they went from 3 compressors to 1 compressor by changing the piping out to AirPro, and eliminated leaks, eliminated the need for tremendous amount of energy costs. They even got some grants back from the power company at this location because of the savings that this piping secured for them. And this is actually, AirPro is a product that this is not uncommon. There's a lot of applications, a lot of industries. Every industry uses air. It's referred to as the fourth utility, beyond water, gas, and electric. And I read just somewhere recently that almost 75 to 80% of every manufacturing facility in the country uses compressed air to some extent. And a lot of them do have underground process lines, if you will, air lines. And over the course of time, they leak. And leaks in air systems are a big concern. There's always evaluations going on. And AirPro is a product that has come in actually to save the day or prevent the day from being lost in a new installation in a number of applications. Another area where we resolve a lot of issues is when a lot of universities and colleges have moved to PP-RCT, the Asahi type product, for their domestic water and even heating and cooling, district heating and cooling systems, because over the course of time, they've just gotten fed up with leaks and mold in dorm rooms and situations like that. They own the facilities. They want long-term maintenance-free service. And so in many universities and colleges around the country. It's a constant, it's a steady changeover that we're seeing from metallic piping to the thermoplastic piping to the PP-RCT to eliminate those leaks and those headaches.
Interesting. Okay. What else have you got?
We've got a lot. We really do. Obviously, we handle the commercial space. High purity piping is another area, again, in universities and labs, pharmaceuticals, semiconductor industry. It's a tremendous amount of high purity, highly refined, ultra pure water that's used, obviously, in the manufacture of pharmaceuticals, in research labs, and also in the manufacture of semiconductor products. And we've got an extensive range of products from a material called Halar, PVDF, various forms of polypropylene, and actually some very refined methods of joining them. We've taken the socket fusion and the butt fusion methods, the basic methods, and enhanced them. We have a method called IR or infrared butt fusion, where it's non-contact to anything but the two weldments. So there's no real possibility of contamination from contacting the weld tool, and it creates a very small internal bead, smooth flow. We have beadless method of joining, which essentially is a totally smooth ID, tantamount or analogous to orbital welding in stainless for pharmaceutical, for stainless steel. So, and we've got a clean room in our Lawrence facility so that we can do fabrication and component construction in a clean environment for application into those markets. So it's another large segment of our sales.
So industries that you guys are the leader in, it sounds like, obviously it sounds like pharmaceutical and so forth like that, but what about water, wastewater, chemical processing pumps of any, go ahead.
Yes, wastewater treatment plants, we see a lot of business. Our valving, our valves are existent in virtually any chemical process facility, manufacturing, wastewater treatment plants, aquariums, for example, use a tremendous amount of our butterfly valves. So in a wastewater treatment plant, for example, we could have our PVDF or Halar material on a highly corrosive chemical injection system. We have a product called ChemProline, which is a polyethylene product that's again specially formulated for sulfuric acid and caustic service, primarily in wastewater treatment plants. We have the full range of valving, gate valves, globe valves, ball valves, butterfly valves, in the appropriate materials and seals so that they can find themselves into those same applications. So wastewater treatment plant, extensive applications within it. Like I said, aquariums, same way. Actuation, we manufacture our own actuation. Quite frankly, they go on our thermoplastic valves, and we also sell them to actuator houses to apply onto metallic valves as well.
But once again, my guest here is Rob Marsiglia with Asahi America. Rob, what cautionary advice do you have out there, or whatever you do, don't do this kind of a thing? So go ahead.
I think the biggest thing that I would stress, and obviously it would be to give us a call, but what we see fairly frequently, even within the thermoplastic market, is a misapplication or maybe too broad an application of polypropylene or PVC. It's relatively common. And sometimes it can be presented as being, I don't want to say a panacea, but as being applicable for more than it should be. One of my colleagues had a conversation yesterday regarding a company that had used, quite frankly, polypropylene for compressed air. And we would frankly say you really shouldn't do that. You should be using either a aluminum piping or our AirPro, polyethylene piping. And as could be expected, the experience with the polypropylene piping was not the greatest that the customer had expected. And then you kind of get worried, because does that broad brush the whole use of thermoplastics in that arena, because it was maybe oversold or misapplied or what have you. We see that with PVC at times, that it's common. It's an economical thermoplastic material. It certainly has tremendous application, but again, it's not a panacea. Temperature, pressure, certain chemicals. So I think what we stress is, again, that knowledge. The back of our business cards all say you're experts in plastics, and we pride ourselves on that. Give us a call, shoot us an email. We have a real good engineering staff supporting us, technical. We go to our suppliers, and we really take pride in not misapplying a product into applications where they should not be, and really applying the proper product to it. We have a very broad range of products, and that's why, because there isn't just one material that is encompasses every application, and even in an application where in general it might be useful, there may be some nuances to that particular service, a little bit of an elevated temperature or cold temperatures, the consideration for expansion and contraction and those types of things, and what valving do you put into it? Is it an abrasive? Is it, a slurry? Can you, what kind of flow rates are you looking for? What type of valve should be? You need an on-off valve? Is it a control valve? Here again, we take all of that into consideration and try to put together a system, a package, piping, valving, the appropriate welding technology to give the customer the best performing system that we can offer.
Okay, interesting. Well, we're getting close to the final comments. Do you have anything to leave us with? And before I go any further, I would encourage anybody that's watched the video that likes it, please like and subscribe and click thumbs up and copy the link and share it to your friends. And certainly give Rob Marsiglia a call with Asahi America, and they are experts in plastic. Rob, you got any parting thoughts or any other products you want to bring up?
I think what I would stress again and ask is that if anyone is looking at a thermoplastic application, whether it be PVC, polypro, corrosion resistant, high purity, give us a call. We're not just most of us, like myself, have been around a long time, and have a pretty broad background in not just thermoplastics, but metallics, pumps, various applications, like I said, high purity water equipment, selection. So I think we as a group, our business development group and our engineering group, bring a tremendous amount of experience to the whole conversation of, hey, I've got this application, or I'm working in this facility and I'm looking to achieve this. We can bring a lot of experience to bear and a lot of real good advice to, like I said, the engineer, the designer, the end user, that can really prove to be valuable. And we enjoy, as you can tell, I could just talk, we enjoy sharing that advice and that knowledge. That's really what we're here for. That's what we live for.
And that's exactly why I'm here, is that I'm trying to captivate this. In the old days, it was capture it on film. Well, I'm capturing it on video in hopes that someday some young engineer that just stumbles into a problem and he goes through the Rolodex and goes, oh, let's see what this Lunch and Learn has to say. And hopefully he'll glean some information. And go ahead, I'm sorry.
You just clicked on something in my mind, something that a cautionary tale.
Sure.
We all do this. You want to find something out, right? Even in our personal life, you want to go and buy a refrigerator, right? So what's the first thing you do? You Google top 10 refrigerators or what have you.
Right.
And you have to be very cautious because from personal experience and even professional experience, what you always see on Google, what comes up online is not always correct technically. And you really need to work through that. And I know more and more that's kind of where we all go, right? We all go to the internet, we all go to social media, and it's wonderful, and it really is. It's quick, it's fast. You reach a lot of people in a very short amount of time, but you still should do a little bit deeper research. Still, fall back on those people who have been around 20, 30, 40 years and can share that experience with you. So just beware of what comes up first on Google. It may not always steer you in the right direction.
Well, that's a perfect way to wrap this one up. That's exactly what I'm trying to achieve here. I'm not knocking any of the search engines that are out there.
Not at all.
I'm saying that there's, there's good. I almost want to say like fatherly advice. Somebody that you trust that just wants to see you succeed. That's what this is all about. And in this particular area, I'm all about pumps and the equipment that it's connected to, whether it be a motor or a valve, even a filter. All these things are part of pumps, and without pumps, the whole world stops if you think about it. So
Sure.
I'm excited to have you on here, and I hope we can do it again. I'd love to bring you and another guest together and talk about valves and the misapplication of valves, and we can go on and on about all kinds of things where
Absolutely. I would look forward to that. I really appreciate this opportunity, Vince. I really was. It's very enjoyable.
It's my pleasure. One more time with your email address.
Certainly. It's RMARSIGLIA at ASAHI-AMERICA.com.
Perfect. Rob, can't thank you enough. It was great to meet you, and hopefully this will help somebody, and you'll also get some calls from it too.
I hope so. And I do appreciate it, Vince. Thank you very much.
My pleasure. Stay tuned. Don't forget to like, subscribe, and share it with your friends. This is Vince Marino with Lunch with Vince.